So compressors are like pumps. I already told that fluid is taking energy from machine, so that is pump. So in that same definition, this is also actually pump. How it is happening? In compressor you are actually compressing. In pump, normal definition, pump actually it is in compressor fluid, you are delivering from one place to another place, you are adding energy to the fluid. In compressor also actually it is compressive flow, so you are compressing, increasing energy. Okay. So there will be two type basically compressor, one will be reciprocating, another will be reciprocating or positive displacement type. And another will be like centrifugal type. So reciprocating or many other type of positive displacement are also possible for compressing gases. So compressor, low pressure to high pressure development will be there. Flash gas compressor are normally characterized by low throughput rate and high differential pressure. Differential pressure is expressed in terms of overall compression ratio. So RT equals PD by PS. So overall compression ratio and PD discharge pressure maybe PSI, whatever unit you use, because finally it will be ratio. PS is suction pressure. So for gas compressor, RT will be like 5 to 20 about. Okay. Booster compressor to increase pressure 2 to 5. 2 to 5. Okay, this RT value. So whenever we are, so we have seen already overall compression ratio RT equals PD by PS. Okay. Now PV diagram. Sometimes there is an indicator diagram also. First you draw one piston cylinder arrangement, then you draw VP. Now piston will be moving from this end A, B. Okay, let's say piston moving from B to A. So what will happen? Initially all valves are closed. Okay, so initial compression will be happening. Okay, so piston, let's say sucking fluid from here, C, D, C your suction valve, D is your delivery valve. Okay, and initially pressure, atmospheric pressure, and you are delivering at higher pressure. Let's say for example cycle pumper. Okay, or roadside cycle pumper. Initially you are lifting up, then you are pushing down. When you are pushing down, initially some gas will be compressed. Okay, so initially you are compressing certain amount of gas. You are compressing certain amount of gas. Then you are reaching up to certain pressure. Then you are delivering that compressed air into your cycle tube. Okay. So you compressed up to this level, then you delivered. So let's say 1 to 2 you compressed, then 2 to 3 you delivered, again 3 to 4 you are lifting up your piston. So when you are lifting up, actually what happens in piston cylinder arrangement, piston is there, cylinder is there. So piston you are moving down, moving towards the top dead center. This is called top dead center, TDC or top dead center. And this is called bottom dead center or BDC, bottom okay. So from piston moving from bottom dead center to top dead center, the piston will not touch the top dead center, it will keep certain amount of gap. That gap is required for mechanical reason, because continuously you cannot hit this top dead center. Okay, so you have to keep certain amount of gap, and again you have to move backward, again forward, backward, forward, that way you are delivering fluid. Now initially you compressed, then you delivered the fluid, then certain compressed gas is here. Now piston is moving backwards, so that compressed gas again it will be expanding. Okay, after certain amount of expansion it will be sucking air, then again compressing, delivering, sucking. So now some expansion will be happening, then again suction will be happening, 3, 4. Okay. So then 1 to 2 adiabatic compression. Okay, I am assuming during when cycle pumper you are compressing, the event is happening very quickly, so it is adiabatic, no heat transfer happening. Okay, if heat transfer happening, then it can be polytropic process. Polytropic means neither adiabatic nor isothermal. Isothermal means it is very good, but we cannot achieve that one. Normally, it will be very fast process. So let's assume it is adiabatic process. 2 to 3 process. 2 to 3 process, it will be delivery process, constant pressure or isobaric, I can say isobaric delivery of air, okay, to your cycle tube. And 3 to 4 actually the amount remaining, the air amount remaining, that is expansion of remaining air in the cylinder. Okay, and 4 to 1 it is happening like this. So 4 to 1 is suction of air, air at constant pressure. Okay, now you can see I said like some amount of air will be compressed, but it will not be delivered. So piston moving BDC to that level is called swept volume. So my swept volume is B to A. B to A is swept volume. Okay, and some part piston is not moving, so that part is called clearance volume. Okay, let's say A, B, C, I will put some name, let's say E. Okay, A, E is called clearance volume. Okay, so piston will not be traveling to clearance volume, so that gap will be maintained all time. Okay, so some compressed gas will be there, again expansion will be happening. Once expansion done, then air intake will happen, again you compress, deliver, again that very highly compressed gas will be expanded a little bit, then air intake will be happening, then delivering. So if you go to a roadside cycle shop, they will have cycle pumper, just you can do experiment also. Initially you take air, try to compress, after certain time only the air will be entering into a tube, you can feel that one. Okay, again you when it moving up quickly, it will be helping you to move up, then after that you have to pull it up, so that atmospheric air will be entering into that cycle pumper, then again you are delivering. Okay, so that whole sequence will be continuously happening. So this is called PV diagram. Okay, this is called PV diagram. So normally adiabatic compression or polytropic compression. Practically it will be polytropic, but ideally we can assume adiabatic. Okay, polytropic means some heat already gone to atmosphere, so you cannot get back that heat, that's why that can be polytropic. Or you cannot make isothermal because the process is not so slow that all heat will be dissipated. So in that case some heat will be remaining, some will be dissipated, so it will be polytropic process.